Hello everybody. Today we're going to learn about linear perspective. That is linear as in line and perspective as in having the long view. And linear perspective is a scientific method developed during the Renaissance in Italy to create the illusion of real and deep space on a flat surface. So it's how to create an illusion. And it has two fundamental concepts. One, that objects appear, they look like, they diminish in size as they get further away. And two, parallel lines appear, again, looks like, they don't actually, but parallel lines appear to converge. So for example, if we have a box and this is the near side of the box, and then there is the other side of the box is further away, so it's going to be smaller. Now, we happen to know that a box has straight sides on all sides. So the top of it, the sides are parallel. The side of it, the sides are parallel. But if I draw the box the way I know it to be, I'm going to end up with something that looks like this. And if I folded that all up, I would end up with a box. But you see, that is how we know the box to be, but that is not how we see it. We actually see that the side that is further away is smaller. And that is the very first fundamental concept of linear perspective. The second fundamental concept is based on the first one. If you connect, if you're going to make a box, you've got to connect the corners. And so if you connect the corners, look what happens to the lines which in reality are parallel, but all of a sudden they're diagonals. And it turns out that if you extend these diagonals into space, they will appear to crisscross. And where they crisscross, we call that the vanishing point. It also happens that all the vanishing points are going to be along a single horizon line. That is another very important word when we are talking about linear perspective. Now, when we are looking straight on at a box, we call that one-point perspective, because all the sides of, if you connect all the corners, they're going to converge at the same vanishing point. And so all the corners converge at one point. It's one-point perspective. Every time that you see the flat side of an object, you are seeing it in one-point perspective. However, it also occurs that we sometimes see not the front of an object. Actually, most of the time, we see the corner of an object is closer to us. And then I'm going to pretend my vanishing points are here. And then it turns out that the right-hand side of the box is going to be diminishing towards the right, and the left side of the box is going to be diminishing towards the left, because we're looking at the corner. And so I can make this a very long box, or I can make it a square box, not a rectangular box. As long as I stay inside these lines, the box will be believable. Okay, so here's what I'm going to do. I'm going to make a box that is long on one side and short on the other. How's that? And if I establish that this is the size of that side, I connect the corner to the vanishing point. And if it's this long, I'm going to connect that vanishing point. And now I have a box that is believable. Look at that. And you see that this one has the left side vanishing towards one point and the right side vanishing towards a second point. So this box is in 2-point perspective. Most of the objects that we see in the real world are placed in all sorts of positions. So most objects are going to be viewed in 2-point perspective. But no matter where they are, no matter where they are located, no matter where their vanishing points are, the vanishing points to all the objects are going to be on the same horizon line. So these boxes, this one is down here, that one's in the middle, that one's on the far right. But these boxes, they all have their own vanishing points, but all of the vanishing points are going to converge at the horizon line. And the horizon line is that line directly in front of the viewer. That is, so we have an eyeball, and whatever is directly aligned, imagine a string that goes from your eyeball to a wall. Or this is, the horizon line is going to be directly in front of the eyeball. So if you are crouching, your horizon line will be very low, and if you're standing, your horizon line is going to be very high. Another interesting thing about horizon lines is that, I'm going to draw another one here. Let's pretend that we have an eyeball. And let's pretend that the eyeball is looking down. Now, whenever you are looking down, you're going to see the top of the object. If you're looking across, you're going to see the side of the object. And so in front of you, the side of the object would look like that. And if you're looking up, of course, you're going to see the bottom of an object. So I'm just going to use those same vanishing points for ease. Let's see. There we go. So when we're looking down below the horizon line, we see the tops. When we're looking across directly into our horizon line, we see the side of an object. And when we are looking up and the objects are above our horizon line, we see the bottom. It's really important to notice that vertical lines are always parallel. Horizontal lines are always parallel. Parallel, parallel, parallel. Parallel, parallel, parallel. The only lines that turn into diagonals are the ones that connect the corners. Those are the diagonals. And this is one of the most common mistakes made right after getting the angles wrong at the bottom. The most common error is that people, you saw how very shallow the top of the box was, but people will draw the box like the top of the box like this. We'll put the corner way up here. And so then this looks as if we were, we're looking at the top of the box from that side, and we're looking at this box from the corner. So we are looking at this box from a bird's eye, as if we were a bird in the sky. But we're not a bird in the sky. We're actually, we're just a little bit higher than the box. So if you cannot figure out why the top of the box looks all wonky, it's probably because you have that far corner too high. Bring it down and find out how far to the right is it from one corner, how far to the left is it from the other corner. It might be between these two corners. Maybe it's not over here. Maybe it's over there. You see? But you want to find out, you want to figure out where exactly is that far away corner. I'm going to turn the box. There we go. See, that makes sense? This makes sense? But that does not make sense. So double check yourselves always on the o'clocks at the bottom, and where exactly is this last corner? Where is it located? And make sure that you don't have it too high up. So that is the very first calculation that a person wants to make visually when you are drawing your corners. You want to say, what o'clock is it? That's number one. And the second thing you want to notice is, well, are you looking at the top of the box? In which case we are, because it's below the horizon line. Or are you looking right directly across at it? Or are you looking at the bottom of the box? And all the still life photographs that I gave you are either straight on, or you are, most of them I believe, you're looking down at the tops. And remember that if you determine this, you have to eyeball how wide is the box on one side, how wide is it on the other. Once you eyeball that, you have to imagine that you know that vanishing point that is way off the page, you have to imagine where it is. You can't draw it, it's way off there. Now this one you can, so we can just draw this one right in. Okay. And turns out that the top of the box, the farthest corner, is going to be about here. And one way that you can find it is to find out how far, where is it? Is it going to be between these two lines? Is it going to be between these two lines? Is it closer to the one? Is it closer to the other? And how far up is it? So you figure out where this line is by finding out how far to the right or to the left it is from the corners. Now we're going to learn how to draw an object using linear perspective, and it's a lot harder to draw an object from real life, because what happens is that when I was demonstrating linear perspective, I was drawing the objects really small, so all the vanishing points fit on the page. But when we're going to be drawing an object, a box, you know, let's say that I'm looking at an object in 2-point perspective, and let's say that if I put my pencil here and I look at the angle of the bottom of the box, and let's say it's right there, and then I'm going to set my pencil, imagine my pencil at the bottom of the corner, and I'm going to see, is this like this, is it like this, is it like this, where is the bottom of the box? And let's pretend it's like this. Now if this is the top, this is the bottom, what happens is that by the time that I use my trusty ruler to follow the horizon, follow the line and see where it converges into a vanishing point, it's going right off the paper, right? So it's like way over there somewhere. Now this is because this is a very shallow side. And my horizon line is around about here, as it turns out, I think. And if the diagonal is very pronounced, then it is possible that that vanishing point is going to fall on the page. And so most of the time, especially if you're drawing an object this size, let's say you have a box and it is that size, well, the vanishing points for this box are going to be way away to the left, to the right, and these are going to be way away over there to the left. These are going to be super far because the diagonals are very, very shallow. These are going to be closer because these diagonals are more pronounced. Now, I am going to show you one of the most common errors that people make when they are drawing boxes. The first thing that you want to do is you want to lay your pencil down and you want to see on the corner, you want to see what are the diagonals. And I like to think of these as the o'clocks. So this is 12 o'clock, this is about 2 o'clock, or maybe it's 1:30.